Good afternoon, everyone. Welcome to the third lecture on sustainable manufacturing. We actually had a long lecture which was broken down into two earlier. So, today we will be doing the third lecture, which is basically on sustainability and manufacturing. And I am Dr. Deepa Philip. I am from IIT Kanpur. So, today's agenda we are going to talk about is understand the concepts of sustainability and what are the factors or the drivers that drive sustainability in an organization, and the major M's that are used in manufacturing, and obviously the viewpoints. How does the hierarchical viewpoint is typically used in doing sustainability analysis. So, these concepts, this term sustainability is an important term for us because we want to understand how this term has come in, and these are the drivers, or in other words, what are the factors that drives sustainability in an organization. Okay. And we will see some of the factors are like positively influencing, or what we call as rewarding kind of a parameter factors, and the other ones are actually what we call as punitive or regulatory factors, in another way to think about it. So, we will see the details of this. Then we also talk about what are the major M's, okay, and that is important to understand that. And the viewpoint, how do we hierarchically analyze the system. So, sustainability, obviously everybody heard about this word sustainability, and the major aspect of sustainability is that the first most important thing is sustain, means it is to maintain or endure. Okay. So, sustainability for that matter is a new paradigm in manufacturing. The concept of sustainability has been there for a long time, but it is a new paradigm in manufacturing. Manufacturing, this concept have been there for some time, and the reason why this is a new paradigm is purely because of the fact that organizations face diverse challenges. And one of the challenge is sustain their operations, or sustain their business, or maintain the business, or let the business be endurable. Okay. So, when we talk about sustainability, sustainability is a development. It is a development that meets the need of the present. So, when we say the need of the present means it can be the present generation, or it can be the present time, however you look at it. The need of the present without compromising the ability of future generation to meet their own needs. So, you are allowed to meet the need of the present generation or present time, without compromising, this is the most important phrase, without compromising the ability of the future generations to meet their needs. So, in a way that if you are able to make let us say we take about this, you have 1 kilogram of raw material from which you can make 500 grams of steel today, okay, present. Then the future generation, let us say this happens in 2017, in 2117, 100 years from now, they should still be able to make this 1 kilogram of raw material, they should be able to make 500 or more of steel. They should be able to do that. Okay. So, that is an important thing. The future generation should also be able to meet their needs. So, that is what the design or the word sustainability is defined. So, if you talk about sustainability in manufacturing, then we talk about it is the ability of the present. We can change the definition. Ability of the present to produce whatever they want to meet the demand, without compromising the capability of the future generation to produce whatever they want to meet the demands. Okay. So, when people talk about sustainable development, a lot of the time sustainability has been more, people used to say it as a sustainability is like an environmental initiative, it has nothing to do with manufacturing. But when we talk about sustainable development, it is actually a balancing effort, okay, or people call it as a balancing act, okay, or a balancing effort to meet human needs without destroying or degrading the environment. A classic example of this is when we talked about green revolution. Green revolution to a large extent was a developmental initiative where your aim was to produce more food grains from same land area. So, for green revolution the major inputs were new seeds, fertilizers, pesticides, new practices, farming practices, machinery, etc. Okay. These were all the big things: machinery, new seeds, fertilizers, pesticides, farming practices, everything put together resulted in something called as a green revolution. But later down the road people realized, yes, you are able to produce more food grains, but in the same process you are also degrading the environment. You have started using pesticides that are organophosphides, organosulfides, which had long lasting adversarial effects on not just human beings, on other life forms. The extensive use of DDT, everybody has studied that, how it has reduced the adversely impact the population of certain birds and stuff like that. So, that type of a revolution which actually produced more food grains, but at the same time harming the environment, was not really a sustainable development. It was a development but not a sustainable development. So, now people talk about something called a sustainable green revolution, which means you are basically doing the you are having efforts to meet the human needs. The human need in a green revolution is food, okay, having food. So, that need you are trying to meet, but at the same time you are not trying to destroy or degrade the quality of the environment. So, that is any sustainable development. So, if you say I am doing sustainable manufacturing, then you are manufacturing the things to meet the needs of the human beings without hampering or without harming the environment. Okay. So, when we talk about the sustainability, and the, as I said earlier, manufacturing organizations, they do face a lot of challenges. Okay. Broadly these challenges, okay, these challenges can be broadly classified into three. Number one, they can be economic. There were economic challenges, typically like shorter product life cycle, then technological changes, we can think about it as demand fluctuations, we can also think about product variety, etc. So, if you look into this scenario, the economic stuff, shorter product life cycle is an important factor that we all need to look into. So, earlier days, if you look into it, let us take an automotive, a car, a model of a car. You take in the earlier days, like in when 60s, 70s and 80s, a product, a car that was designed by a company like a Mercedes S-Class, that was W210 or something like that, that was designed, it typically used to live, that life cycle of the product used to be 10 to 15 years. It definitely overshot a decade. So, the product had a long life cycle. You built a car, it used to be in sale for 15 years or for 10 to 15 years. Now, if you look at the current in 2015 or 2017 car manufacturers, their life cycle of models are not any more than like 5 to 6 years. By the time you come up with a new model, you are basically like, okay, this model is outdated. It's very few vehicles at this point have longer product life cycle. Earlier days it was the same thing with mobile phones. If you look at the Motorola Star Trek, that model which is a flip phone, mobile phone, which lasted quite about 8-10 years. Now any of the mobile phones are produced, they don't have that long of a life cycle. So the product life cycle becoming short literally means that the manufacturing organizations are forced to bring up with new products to meet the competition quickly. So that means you are also, what happened to the old product then? You can't consume them, you basically throw them away. So it also adversely impacts the environment. Technological changes is another example. Earlier in the mobile technology, the earlier days time of technological obsolescence, it used to be in mobile technology, used to be 2 to 3 years. Now it has come down to what you call as 6 to 7 months. So when the technology changes so rapidly, you want to change, you want to bring new products that imbibe these technological changes. Demand fluctuations, another example. As people used to say in India, every time a pay revision comes into picture, more and more people move into the middle class or upper middle class. So the standard of living, increased standard of living contributes to larger middle class. In earlier days, for example, people talk about air conditioner. In earlier days, air conditioner used to be a luxury, and nowadays it has become a necessity for many people. So this is an example of how demand fluctuates. Okay. In earlier days, the demand for air conditioners in India was very small. Now during the summer season, the air conditioner demand goes through the roof because more people can afford air conditioner. Similarly, variety of the product. Everybody in this case, if you remember the product called, I am talking about this as Ambassador car, again manufactured by Hindustan Motors. If you look at it, they had 1 or 2 models. They are following the old tradition. Okay, if you are building a car, maybe 1 maximum 2 models are sufficient. Now you look at any of the new manufacturers, they have like LX, GX, VX, DX, E, all alphabets in the English that are used for naming the models. So larger product variety is also required. Some people says I want power windows, some people says I want all airbags, some people says I want all leather seats, this particular color. So depending upon the features and creature comfort that is added into the system, the variety of the product also changes. So all these challenges, these are typically economic in nature, or what happens is these are basically driven by the economics of the system. The second we can talk about is the environmental challenges. What do we mean by the environmental challenges? One example is the climate change. Now we can talk about as the depletion of natural resources, etc. So when we talk about climate change, everybody hears about this, right? That the temperature of earth is increasing, okay, and in that process the Arctic ice will melt, flood, all those kind of things, which in a way we called as greenhouse effect and those kind of stuff, or pollution. There are many ways people talk about this. Then similarly we say there is a depletion of natural resources like crude oil. People say that until 2050 the crude oil reserve of the world will be over, something like that. So the environmental challenges is also another aspect that is being forced into the manufacturing. So earlier people used to, like in an example is in 1970s in this regard. In 1970s, if you look at the history of United States, you can find that up to that point United States used to drive cars that were not fuel efficient. because gasoline was very cheap. And then all of a sudden the price of gasoline increased, and because of the scarcity and all other kind of things. And guess what? People started looking into cars that had better mileage. So then you were like, okay, I want to drive a car that will actually consume less amount of gasoline or petrol, so that, or increased mileage per liter of petrol that I use in the car, so that my petrol consumption reduces, my money is saved. So by doing that, what has happened is the reserve of the depletion of the crude oil has reduced. The rate at which it was being depleted got reduced. If the cars were not fuel efficient, there would have been no crude oil available or no petrol available for the vehicles to move around. So these kind of challenges are also faced by the manufacturing systems. Then come the third challenge, which we call as a societal challenge. Some examples of this is aging workforce. We can also think about as non-availability of skilled manpower, etc. A classical example of the aging workforce is if you think about the country called Japan. Okay. The workforce is really aging. You will see people who are 70, 80 and all working, still continue to work because there is not sufficiently available manpower to do the work. So that's one thing. Another is the non-availability of skilled manpower. So you might be able to get manpower, but you might not be able to get the skilled manpower. So when you talk about initiatives like Skill India and all, this is like the aim of create manpower with the skill that is necessary to be part of the society or be part of the manufacturing, production, services processes. So these challenges, these different challenges, the societal, the environmental, the economic, these challenges, all three put together, put different type of stresses or requirements or needs for the manufacturing organizations. And these challenges in some sense contribute to or force the manufacturing systems to be more focusing towards sustainable development, where they would be looking at how do we conserve the resources what we have, how do we do manufacturing without compromising the capability of the future generations, etc. So in thinking in these lines, we can next get into the concept of what are the factors or what are the drivers that drive the concept of sustainability in a system called manufacturing. So typically the old school, the traditional manufacturing, if you think about it, traditional manufacturing had major, the three major factors. You can think about it as cost, time and quality. Talk about cost, time and quality as the traditional manufacturing thing. Whereas in the modern manufacturing thing, what we talk about it is the, to this we add the environment driven objectives. Then we get what we call as sustainable manufacturing. Okay. So the major drivers of it, I would classify the drivers of it into five categories. We will try to look into what these 5 categories are. So the number 1, we call it as the market factors or market drivers. The market drivers include customer requirements, then demand changes, then there is cost increase. We will see what all these factors later down the road. Resources depletion, etc. The second set of drivers, we can call it as the technology drivers. What are those drivers? They will be efficient processes, then new manufacturing philosophy. We can think about it as 3D printing is an example. We will talk about this later. Then we talk about societal drivers, which are global warming. These are some examples or representative things about it. Corporate image, then NGOs, etc. We will look into each one of them after we list all of them down. The fourth one we can call it as regulative factors or regulative drivers. Regulative drivers. These include like things like emission norms, energy limits, then carbon credits, then we have is government initiatives, research funding, penalties, etc. Okay. And then the fifth one we talk about is the vision or visionary drivers. This is like self-commitment, then we also have something called as corporate image, etc. So if you look into this scenario, the 5 categories, the market drivers, as said earlier, any manufacturing firm, the aim is that you have a transformation process, you have raw materials coming from one side and you have a transformation process, and then you get the products outside. These products need to be sold in the market, okay, sold in the market to generate more money so that you can sustain this process, okay. This is where the money comes into picture. So when you have a system like that, the market drivers, this market, this economy is the one that is very powerful and can actually make the manufacturing system accomplish things as required. So some of them will be customer requirements. Like a classical example of the changing customer requirements is a company called Tesla, who makes electric cars. In earlier days, there are so many companies who was attempted at making electric cars and nothing survived very well because people were like, it was inconvenient. But now when you look at cars like Tesla, Model S or whatever you see around, and when the charging stations are available and stuff like that, people started moving more towards electric systems. Same is with the e-rickshaws, electric rickshaws across the country, and different major cities uses e-rickshaws because there is charging and battery availability. Similarly, the changes in demand. Earlier people used to buy big cars, but now if you go to Europe, in many places people are moving towards compact cars. So the change in the demand of compact cars all of a sudden increased rapidly. Another one is cost increase. Another example is how the parking space or parking fees increases or the cost of maintaining a car. Like if you go to Singapore or big cities like that, you will actually find that people tend to use more public transport system rather than maintaining a car because the cost of maintaining a car is extremely large. Resource depletion is another example where if you keep on consuming the iron ore, at some point of time the iron ore is not available from the earth, then you will have problem making steel. So you should be very careful about that part as well. So these kind of market, both the raw material and as well as the finished good markets, to a large extent do drive the need of sustainability into the manufacturing system. So the market drivers are one factor that actually force the hands of manufacturing organizations to be conscious about the environmental objectives. Second factor that we talked about, which is the technological drivers, okay, those are outcome of the modernization technology or the modern processes that are coming out of it. So one example is that when we are able to develop efficient processes or like efficient machines, The classic example of this is CNC machines, okay, computer numerical control machines. So, these machines are way much more efficient in manufacturing a part depending upon the drawing that you are given, or what we can think about it as FMS, flexible manufacturing systems, is another example of an efficient process where the entire manufacturing process is being made much more efficient than what is normally in the conventional way. Then there is another example of this is the new manufacturing process or 3D printing, or what we call it as additive manufacturing. It is called additive manufacturing because classical manufacturing, you take a raw material and use different machining processes like turning, drilling, grinding, all those kind of things, milling, those kind of things, where you are basically focusing on removing the material and then getting the finished product. Whereas in 3D printing, it is more following the nature's approach, the environmentally conscious approach of you are adding the material to get the final product. So, the wastage, the aim of the additive manufacturing is more to minimize the waste, because in any other manufacturing process, whenever you are doing drilling, milling or something, the metal parts or the scrap that we call about, or actually the cut bits that comes out of it, or the metal shavings that comes out of it, is actually a waste which need to be disposed. Whereas in additive manufacturing, that kind of a problem can be sorted out. Then comes the societal drivers. Classic example of this is there are quite a lot of thought processes that goes about. One is the global warming. Everybody talks about global warming. Everybody says that okay, the ice is going to melt and it is going to increase the sea level and the whole world will be submerged under water. And the climate studies experts have been talking about the adverse effect of greenhouse gases, carbon dioxide, on increasing the temperature of the earth. So, everybody knows about that. Same way, it's a corporate image. Like for example, when we talk about certain public sector companies, people might say, oh, these guys are a big polluting company. Whereas some people, when we talk about certain other companies, they will have a very good positive oh, they are environmentally supportive in nature. They produce it, they do a lot of environmental stuff. Then there are NGOs. NGOs is non-governmental organizations. They are non-profit organizations. Classic example of it is Greenpeace and all kind of things, who actually try to increase awareness against organizations that do not do environmental protection, or they are not being conscious about environmental impacts of what they are doing. So, these are the factors from the social side or the social societal aspects that actually drive or force the manufacturing organizations to consider the environmentally driven objectives as well. Then some of these, as I said earlier, like for example the corporate image and those kind of things, these are incentive kind of things. Like for example, Johnson and Johnson, we will probably discuss the case some point of time, how they became one of the most loved company, or people consider that as a sustainable organization, those kind of stuff. So, we will see that at some point of time. Then we study about regulatory drivers. Regulatory drivers are kind of basically, can think about them, or some of them are, a lot of them are punitive in nature, or if you violate them then you get punished. So, like for example is emission norms. So, in vehicles, when the government came with the Bharat stage 4 emission norms, when it was implemented on the trucks or commercial vehicles, many of the manufacturers in India were caught at a tough situation where they could not even actually sell a product. Because none of the trucks were actually being ready for the Bharat stage 4 emission norms. So, and if you sell a truck which does not meet the emission norms, then your truck will, or your vehicle will be confiscated and you will be fined and those kind of things. So, there is legal aspects that goes along with it. Similarly, other things is about energy limits. You can also see water limits, like for example, the amount of water is limited in major cities for 130 liters a day. Similarly, energy can also be limited by you can consume at the max of this many units day or a week or whatever it is. Similarly, carbon credits is another initiative that has happened. This is not a punitive thing. This is actually more of a rewarding initiative. Like if you end up reducing your carbon credits, or if you reduce the carbon dioxide emissions from your facility, then obviously you can use that reduced quantity to gain subsidy on things. And this was initiative that is put by the government, which is not of a regulatory in nature, but it is more of a rewarding in nature. Then there are other government initiatives like Swachh Bharat Abhiyan is another example, where you like to say that okay, the development of the country should also focus on environmental aspects of it. So that is another thing. Then there is about research funding, like for example, there could be schemes like National Science Foundation scheme says, okay, fine, if your organization is working on environmental initiatives which will actually minimize the impact of climate change, then there is additional research funding available for that. So those kind of research funding might even drive the organizations towards achieving sustainability. Then and penalties, like if the organization finds is found that if you are dumping pollutants into the atmosphere or the land or water bodies or something like that, then the pollution control board, like an example is the pollution control board, who actually find out whether you are whether you are being conscious about the environmental impacts. If you are not conscious, then a fine is taken away. Like classic example of this is the Volkswagen group, who has been fined by the various bodies in the world for cheating the emission norms. So these kind of things are example. Then the fifth one is the visionary drivers. Visionary drivers is more like the vision that is related to the organization, or it's the leadership of the organization who drives this. So to a large extent, there are certain organizations who are self-committed. We will act, like Tesla is an example. They are committed towards the cause of minimizing pollution due to the fossil fuels. So they focus a lot towards building electric vehicles. Then similarly, the corporate image. Certain times the corporations are worried about the corporate image, how people perceive the company, and depending upon how they perceive the company, the people might be interested in buying the product or not. So these kind of visionary, how you envision yourself, how the top management of the organization is interested in following these or championing the environmental objectives or environment focused objectives along with the traditional cost, time and quality objectives of the manufacturing. That is that's the point at which the typical traditional manufacturing becomes or moves towards becoming sustainable manufacturing. We are still talking sustainable manufacturing, and in between you might be worried or you might be thinking, where did this green manufacturing comes into picture? Green is one aspect where you are actually talking about minimizing the energy consumption, or you are also focusing more towards using renewable energy sources and those kind of stuff. Now, one other way I would like to talk about this is we can think about a system, a diagram in which you have a manufacturing, which is also a transformation process. And what are we doing in this transformation process? We get raw materials from one side, and these raw materials along with energy, you utilize energy and you create products. The case of manufacturing, the case of otherwise it's services, and from here you also create what we call as byproducts. Okay. Some of them can be wanted byproducts, some can be unwanted byproducts. So unwanted, you can call it as pollutants and stuff like that. Okay. So so this is the typical manufacturing system in which you take raw materials, energy to produce the products. In the same way you create byproducts. So one aspect of this is the when we talk about this, the environmental or environmentally driven objectives. These objectives include low CO2 emissions, minimize utilization of natural resources, minimize energy usage, etc. Okay. So, these environmentally driven objectives, when added to the manufacturing system together, so where you are basically saying that, okay, I want to reduce the unwanted emissions, I want to minimize them, I want to reduce raw materials, I want to maintain the same products or production, I want to reduce energy, okay, or find substitutes. Okay. So, wanted raw materials will say recycle slash reuse. Okay. All these kind of things put together make you move towards sustainable or green manufacturing when we talk about. In this course, we will use the term sustainable and green manufacturing in an interchangeable format because it is necessary for us to understand it that way. Now, we talk about the M's of manufacturing. Many a times people talk about there is multiple M's that is related to manufacturing, and the most common 5 M's, initially we talk about it as man. Okay. This is the human resource. Second is the materials. It can be, you can think about it as raw materials, and then you can think about it as additional or accessories like coolant and stuff like that. You can think about third one as machines, different type of machines. Many a times people call it as resources. The common term resource also refers to machines in simulations typically. The fourth one is methods, or the simpler term to it is processes, and fifth one is money, or the simpler term to this is finance. So, these 5 M's are the typical factors that influence manufacturing. So, there are many aims to this. If you think about the human resource, then you can say there is like reduce manpower requirement is one goal, which would be translated to increase automation or increase automation. Another example is enhance skills, like Japanese do, cross training, stuff like that. So, these are all aspects related to man or human resources. In materials, you will say appropriate raw materials, reduce the consumption, etc. Okay. Additional and accessories, similar aspects you can think about it is machines, right machine that can maintain quality and speed, etc. So, find which is the machine to do, right machine to do the job. Methods, or what we call as processes, is the what we say how to produce a product. So, like for example, if you think about it, let us say you have this as your workpiece, rectangular workpiece, and you want to put a hole in between of some dimension. You can use a drilling machine to do this. Okay. As one option, or you can use a what you call as a blanking operations, a blank. Okay, you can punch a hole through it. So, depending upon how you want to do the hole, based on the finish and other requirement, choosing the appropriate technology is an important thing. Then obviously finance. Okay, how to minimize the cost of manufacturing. So, an example would be sometimes one of the most expensive thing is that you end up using is the mineral oil or for coolant when you are doing machining. So, if you are machining a very complicated part, then the coolant usage will be also be pretty high. And at some point of time, let us say you came up with a nice method to substitute the coolant, the mineral oil, with vegetable oil, which is cheaper, then that will reduce your financial requirements. So, these are the typical 5 M's that everybody considers. We now add one more M to this, which we call it as Mother Nature. Okay. Or in a simpler sense, let us talk about it as what we call as environmental. So, in a way, here we talk about is the environmental factors. Okay. So, one way to think about this is we discuss the environmental factors like minimize the societal impact, minimize carbon dioxide emissions, reduce energy, all those kind of things. So, if you think about all these things, then by managing these factors, you would be able to create a manufacturing system which is more sustainable. So, if you think about this, think about each M, we can think about each M as a dial. Okay. So, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, something like this. Another dial might go from 1, 2, 3, 4, 5, 6, something like this. Another dial might be A, B, C, D, E, F, G, something like this. The another dial will be again somewhere here 4, 5, 6, 7, 8, 1, 2, 3, something like this. So, if this can be the man, this can be the machine, this can be the methods, this can be like Mother Nature, all these kind of things. You can think about 6 dials like these, and each of these dials, by turning them, by moving them around from different settings, by changing the settings, the system can achieve variety of goals. Some of these goals actually include, number 1 would be, become energy efficient. Here, one thing that you might be doing is, you might be changing the dial of the methods or the process, so that the process utilizes less energy. Another example of this you can think about it is reduce or eliminate consumption of non-biodegradable materials. This is where you are actually influencing the M of material M, where you are reducing the consumption of a particular type of a material, or you are making the dial turn to 0. So, then you are thereby achieving whatever you are supposed to achieve. Let us look at another example also. We can think about it as minimize adverse impacts of noise, aerosol, etc. This is another example. So, if you are coming up with a new machine which will actually reduce the noise pollution, then that is actually a good thing. So, there you are influencing the machine aspect of it. An aerosol is where the spray or the let us say, for example, your process has a very high speed cutting drill or a drill bit which is running at a high speed, then and the coolant is touching, when it comes in contact with that, it will actually become very fine particles or a fine spray which becomes an aerosol, and most of these cutting fluids are chloride or sulfides based mineral oils, which can actually create a much dangerous health hazard to the worker. So, here you are thinking about the man aspect, the human aspect, the better work environment, those kind of stuff. Okay. And another example of this can also be, fourth one can be reduce waste is another example. Okay. All of these, if you think about it, all of these are good. You can keep on attaining, changing the dials, but you should also maintain necessary production to satisfy customer demand. And what we call here is that there is something, this maintain the necessary production to satisfy customer demand. There is a nice term that exists for this, that is called as throughput. So, for example, if you are making 400 units of something product and you are having an 8-hour shift to make this, then 8 hours is 8 times 60 for 80 minutes. So, if you have 480 minutes and you have to make 400 units, so then we can find out how many units you need to make per minute. So if it says, okay, you have to make more than 1 unit a minute, 1.2 units a minute, then you will be like, okay, or in other words, if you find out how many minutes are required, or within how many minutes you should make one product, you take the 1 hour of this ratio, then you will be able to get that value as well. So then this is the throughput that you need to maintain. So if you have to maintain the throughput to satisfy your demand, then how can you maintain the throughput? By achieving all these environmental initiatives is one of the major aspects of sustainable manufacturing. And we will conclude this discussion about the sustainable manufacturing on looking into the concept of hierarchical viewpoint. And the hierarchical viewpoint is nothing complicated. It is actually, this viewpoint is necessary because the entire time when we are talking about sustainable manufacturing, we are actually using this as an analysis process. So let's look at the first viewpoint of the factory. Okay, so there is a factory available someplace, a big factory in which there are so many processes goes on. There is one process, products arrive, go through them, and the final products come out. Here is another one that actually happens here, and then so different processes happens. So the input of this is, number one is the customer requirements or customer demand. We said earlier that you have to satisfy the demand of the customer, and then you also give one input called raw materials. These two inputs will provide what typically we call as orders, or in another way, these are products collected. So I might order 5 cars, then all those 5 cars put together will be the order, and I will also end up producing what I call as waste. Okay. So in a factory level, on a very global level, this is what we talk about. Then if you just look at this concept of it, okay, then we are looking at what we call as the next one, which is the system view or the manufacturing system. So this is a lower level, a lower hierarchy of the factory. Okay, so this is a lower hierarchy. You are digging deeper, you are looking more closely into this. Here you have again a collection of machines, as I said earlier, arranged in a particular sequence so that the product moves from one machine to another, you get the final product coming out of it. So here the input is your resources, which include human resources, etc., raw materials, obviously, or materials, if you want to call it that way. And then you also have, instead of the customer demand, you have a production plan. So the customer demand gets translated to what you call as a production plan, and type of raw materials that need to be taken. From there, you will get what you call as products, individual products. You also generate what we call as waste, and you also create what we call as emissions. So when you combine these products, all of these products put together, combined for a customer, gives you what you call as an order. So, all the products that are ordered by a customer, when it is put together and delivered to the customer, that is called as an order. Then if you take one of these, you look at it further. Okay. This is what we call as the process view or the process level of the system, where you are basically looking at a particular machine view. You are looking at the machine that is delivering or creating a part. So, here you have again resources. Resources could include electricity, water, heating, cooling, lighting, those kind of things. You have what we call as materials or raw materials, whatever you want to call it, and then you have information. The production plan gets translated to information. So, it says take this particular raw material, use this particular tool bit and use this coolant and do this type of machining for next 3 minutes, then you will be able to get this particular part. So, here the output is a what we call as a part or a parts. So, we are looking at individual parts, and parts are combined to make products. So, the machine view, machine produces the parts. We also will obviously produce waste, you will also end up producing emissions. So, to make a green manufacturing or a sustainable manufacturing, okay, you are looking at the hierarchy, it keeps going down, the hierarchy goes down. As we follow, the hierarchy is low this way. But as we go down the system, we need to, the aim of way to achieve sustainability in manufacturing is to start looking at process levels. So, if you are able to achieve sustainability in the process level itself, then processes combine to become a manufacturing system or a production line, and production lines combine to become a factory. So, as you move up in the level of hierarchy, higher up in the level of abstraction, then you will be able to obtain sustainability for the entire factory level. So, you will start at the process and you move up to the system, manufacturing system, then you move up to the factory, and that is exactly what we will be discussing in this class, is how to achieve sustainability through this hierarchical viewpoint, or analyzing the manufacturing system at different hierarchy. How do we able to get that? With this, we come to the conclusion of today's lecture. We hope you are able to understand the much more details of the technical or technological background and the philosophy behind this thought process. And from the next lecture onwards, we will be looking into the necessary tools that are required to do these kind of a hierarchical analysis of a manufacturing system. Thank you very much for your patient listening.